I'm going to go ahead and start, guys. You can go and finish up writing that down somewhere. So we're going to go from just knowing the values of all these. So if you think about it, guys, what we've asked you is to find the sine, cosine, tangent of x values. We've given you some radians or some degrees, which is your x value, and you've given us an answer, which is the y value. So if you think about it, guys, you've been constructing coordinates this whole time. You've been given an x, and you answer and you give the y. It's the same idea as 2x plus 1. What is y when x equals 2? Oh, 2 times 2 plus 1 is 5, so 2 comma 5. If I was to graph it, I would put 2 comma 5 is one of the points on the graph if I was to graph it. Same thing applies here. Now what we're doing is we're taking trig functions and we're applying it onto a graph. So now we're graphing it. So the days of you looking at it in a unit circle like you see up here in the upper right hand side, coordinates all around a circle. Now we're going to take those coordinates and put it on a graph and see what it looks like. So first thing we're going to start off with is sine function. And let's start off by using a t-chart. Of course, you can either be degrees or radians. As a matter of fact, we'll just go ahead and leave it like this because I'm going to do it in radians. So let's start off. The first thing is, what is the sine of 0? Well, look at your square root thing. Look where radians is 0. What is the number next to sine? 0. So if x is equal to 0, what is the sine of 0? So guess what? Our first point will be right on the origin. Is that Evan's music? God, yeah. It's all good. All right. Let's move on to 1. Well, I'll go ahead and do this for you guys. This point right here is where we start off with. That's 0 radians, guys, is where that point is on the circle. And we have the coordinates 1, 0, and you guys said it's sine, which is 0, and you're exactly right. Let's move on to pi over 2, which is up here. What's the coordinate for that point? 0, 1. So what is the y value? 1. Oops, I'm sorry, guys. It's not 1. It's pi over 2. My bad. Your x's are all going to be radians or degrees. Your x's will always be radians or degrees. Move on to the next thing on the circle, which is going to be pi. What is the coordinates for that point? -1, 0. What is the y value there? Oh, got a lot of things going on. All right, so go back to pi over 2. Pi over 2, what was the sine of pi over 2 again, guys? What was the sine of pi over 2? 1. So I go over to pi over 2, go up to 1. There's my point. So I'm going to go ahead and put a point right there. What was the sine of pi? 0. So that brings us back down to the x-axis. Still going around the circle, the next thing we get up to is 3 pi over 2. What is the coordinates for 3 pi over 2? 0, -1. And so we have 0. So the answer is going to be the sine of 3 pi over 2 is -1. Let's graph those coordinates. And then finally, let's end up back where we started. Remember, 2 pi is one full circle around. 2 pi. And we go back to where we started, what is the value that we first started with? 0. Trig functions are also known as cyclic functions. Cyclic functions, the root word is cycle. And what the word cycle means, it hits a pattern and keeps repeating. It's a cycle. It goes through one full cycle. So as if you look here, guys, we've went around the circle once. We have created these dots by going around the circle once. And what happens when I start back again to where I'm at? It's going to do the exact same thing. So if you look at those coordinates, 0, 1, 0, negative 1, 0, 1, 0, negative 1. It's going to repeat because we're going in a circle, right? We're going in a circle. All those coordinates will repeat itself. So a sine, cosine function and tangent functions will repeat itself. It hits a pattern and it starts to repeat over and over and over again. So let's go ahead and connect these dots. I do not want you to connect them like this. Okay, that's not how a sine curve looks. It has to be a curve. So you have to have smooth, rounded graph. And as you notice, guys, where we started is exactly where we stop, because the cycle has to repeat itself. Anytime you draw this function and you find out you're ending in a different spot that you started, you've done something wrong. Go back and look again. Those are just little red flags that you can see along the way. Make sure you start and stop at the same point. Okay? All right. There's sine. Now let's go ahead and look at cosine. Getting off to the side. You have the circle there already filled out. We'll do 0, pi over 2, pi, 3 pi over 2, and 2 pi. What is the x-coordinate for 0 radians? No. What is the x-coordinate for 0 radians? Go back up to the circle. 0 is the positive x. Look at the coordinates for the positive x. I don't have a circle close by or else I would. Here. What's that coordinate right there? 1, 0, right? What's the x value there? Or you could look at your square root and say at 0, look at cosine. What's the number next to cosine, guys, on the square root? Look at your square root. Go to cosine. Go across. Do you see cosine is what? Square root of? 4. What's the square root of 4? 2 divided by 2 is, and there's why it's 1. All right, pi over 2. So what is the cosine of pi over 2? So moving around here, this coordinate ends up being 0, 1. So what's the x-coordinate there? 0. So next value is 0. You can only guess what the next answer is going to be. Be careful. Look at the sign one. Yes, negative 1. 3 pi over 2. 0. And then 2 pi is where we started, which is what? 1. So now we go ahead and plot these points. So at 0, we start at the top. Pi over 2, we hit 0. Pi, we hit negative 1. 3 pi over 2, 0. Back to where we started. To give us this type of slope. Notice your start and stopping at the same spot so this cycle can repeat. So there's your parent functions for sine and cosine. No transformations being done. All it is, what's the cosine of 0, cosine of pi over 2. You notice, guys, you have to plot 5 points. Okay? You have to plot 5 points in order to come up with a full cycle and graph it in order to make it work. So please be aware of that, 5 points. And usually it's going to be 0, pi over 2, pi, 3 pi over 2, and 0. What are those values? So there's a parent function. All right. So now when we talk about parent functions, that means we're talking about transformations. Well, let's see what the equation looks like when we break down transformations. I am never going to be able to get all this stuff to fit into one, am I? Great. So if you look here, amplitude. Amplitude is going to tell you a vertical stretch. It's a number in front. It's the same thing you've always seen in all the functions you've done. All of Algebra 2, what we did last semester, it is the idea of there's a number in front of the equation that represents a vertical stretch or compression. Right, Ellie? Yes. So, amplitude represents how far up you go and how far down you go. It represents your max and your min. Now, I should say this too, if A is less than 0, then what has happened, guys? If it's negative in front, what does that mean? What does negative in front do? Good. Or we like to say flip it, right? Right? But yeah, reflection or flipping it. Exactly. So this distance that you go up is A, and the distance you go down is also A. So that means, guys, if we're to go ahead and translate it, that means this. Your range will be 2 times A. Your range, if I was to say, how tall is this sine function? Well, you take your amplitude and you double it. Because you're going up, let's say 2, and you're going down 2, which means that gap is 4. So there's your amplitude. Going on to period. Period talks about and says, how long does it take it to complete one cycle? So we go through and we say, all right, if we start and stop, well, look up above. Look up above for our ones we just did. How long, what's the distance along the x-axis it did to complete one full cycle? 2 pi. 2 pi. It takes a parent function, sine and cosine, 2 pi to complete one cycle. That can also be compressed or stretched as well. And you should look, the location of where B is. B is in front of the x. And as history has taught us that there is a number in front of x that talks about a horizontal stretch or compression. Number in front, vertical stretch compression. Inside, horizontal stretch and compression. So period is 2 pi. However, sometimes it's hard to write that, so we say, okay, let's go ahead and use a calculation to figure out what that is. And so you end up taking B and you divide it by 2 pi. When you divide that, you find out that distance it takes for one full cycle to complete. So if B is 2, what's 2 pi divided by 2? It's pi by itself, which means now, let's say we're doing the cosine function. I start here, I go down, and come back up. That won't take 2 pi anymore. Now, it's going to take pi to do it. So it's being compressed. Because it used to take 2 pi to do a full cycle, now it only takes pi to do a full cycle. What about if B is equal to 1/2? What's 2 pi divided by 1/2? 4 pi. So now 2 pi turns into 4 pi. So now it's a large stretch, right? Because it's 1/2. So just keep that in mind. You'll see what that looks like in just a moment, but for now, just keep that in mind. All right, phase shift. Phase shift is a way of saying horizontal shift. So, left, right. This should all look familiar as well because what you notice is the letter C. What math function is in front of the letter C? What math function is in front of the letter C? Minus. which is uncommon because usually we see plus in all of these type of equations. Why is minus there? What does that tell us? Not down. We're doing horizontal. It is going to the opposite direction. That's what a minus sign in this equation here. Remember, guys, this is the transformation equation. This is not a problem. This is the basic transformation equation. Since there's a minus sign in here, and this, guys, you already know. You've already done it last semester. That is, if it ends up being x plus 7, that means you're going to have to not shift in the positive direction, but you got to shift into the negative 7 direction. Does that make sense? You guys remember if there's parentheses, you do the opposite direction. There's parentheses. So parentheses x plus 7 means we're shifting to the left 7. Okay? X minus 7 means we're shifting to the right 7 because it's positive. All right. And then finally, the last one is that number on the end, which is always the easier one pretty much, and that is going to be vertical shift. Well, I just wrote the same thing that's already on there. That's awesome. Let's do this. It means up or down, whatever D is. I went ahead under phase shift, horizontal shift, I went ahead and put opposite direction. Just to remind you, if the equation, like example 2, example 2 has plus pi over 2. Which way are we going to shift, guys? To the left. Good job. You guys got it. All right, let's go and look at some examples. Here we go. Oops. First thing, when you go through and do this, guys, please do this one part at a time. Don't jump into just a graph. That makes it really, really hard to do. I would identify the parts first. The first thing goes on and says, what's the period? Well, what number is in front of the variable? 2. So, as we saw earlier, 2 pi over 2, and that equals pi. So now our full cycle has to take the distance of pi to be completed. What about the amplitude? Well, what is the number, not the sign, but what's the number that's in front? 1. So it's an amplitude of 1, which means we're just going to start from the middle and go up 1 and down 1 whenever we do this. Let's go and identify the other parts. Is there a phase shift or horizontal shift here, guys? In the parentheses, is there a plus or minus? No. So there is no horizontal or phase shift. What about a vertical shift? Yes, what is that? Up 1. So not only do we have an amplitude of 1, which means that this graph is going to be this tall, but now we have to move it up as well. So we got to be concerned about that. We got to make that aware. And then finally, what's the last thing that's here that we have not addressed? The negative. I mean, there's a flip involved somewhere, right? All right, let me show you how this is done, guys. I found this process to be kind of the best steps to get through this. First is identify where your center is, okay? Which means, is there any vertical shifting? Yes, what is it? Up 1. So I'm going to draw a new dashed line to represent my new center. It's not the x-axis anymore, guys. It was when we first did this in the parent function. However, now what you're looking at is a shift of up 1. So I'm drawing a new x-axis using dashed lines. Now I'm going to go ahead and find out what my new max line is, which means how high up is this thing going to go? Well, it has the amplitude of what? Of 1. So here's my new center. I'm going to go up 1 because it's amplitude of 1. Caleb, you good? You done? Man, we're just getting warmed up, buddy. Okay, good. Can you watch, though? Okay, we need all senses on. So I'm going to go up 1, and I'm going to draw another dashed line to represent my max, which means this is how high the graph's going to go. So when you did the sine function, guys, originally, you started in the center, you started at the origin, then you went up to the max, then you came back down to the min, and then you went up to the center. Cosine, you started at the max, you went down to the min and came back up to the max. So that's what that line at the top represents as your maximum value. And of course, if it's amplitude, that's how far up you're going and also how far down you're going. So what is that distance again? 1. So I'm going to draw another dashed line to represent my minimum. So now it kind of looks like those dashed lines you did in elementary school when you're learning how to write in French, right? It's crazy. My daughter is 4, and they've already taught her how to write out the whole alphabet. That seemed like, I didn't think it happened until like elementary school. It seemed to be pushed off earlier and earlier. I thought I remember like in first grade I was learning how to write. I guess, well, that's small town school, so I guess they push everything back. I don't know. But it just seems so weird how early they're starting you guys out. All right. Is there a horizontal shift here, guys? Are we moving left or right any at all? No. So what I like to do is just to go ahead and reiterate where the starting line is. It's my y-axis, which is still the y-axis. So I just draw a line right above it to let me know where I'm starting, okay? So here's what we've done so far, guys. We've talked about a vertical shift to talk about a center. We've used the amplitude to say where our max and min is. We've talked about then, is there a shift left or right to talk about where our starting point is. That's where we're at now, okay? Now we go ahead and start plotting some points. Sine. Look back up at sine, guys. Where does sine start? Max, middle, or min? In the middle. So I'm going to go ahead and put a dot. Starting line, and sine starts in the middle. Which means it's going to stop where, guys? In the middle as well. Now let me ask you the question. What's the distance it takes to do that? Very good. So that means I'm going to go out to pi and put another dot that represents where I stop. You put your start. You use your period to figure out where you stop. And now we're going to take this gap and split it into quarters, okay? Which means half. Halfway through, guys, look at your sine function. Halfway through, where does it pass? Max, middle, or min? Middle again. If you look, sine starts at the origin, goes up to the max, comes down to the middle again, halfway through, then goes down to your min, and comes back up to the middle, right? So far we're following what happens. Now, guys, look in this first half. What happens to the parent graph? Does it go up to its max or does it go down to its min? It's max, but go ahead. Its parent function is max. However, Allie is pointing out the fact there's a negative sign in front, which means it is flipped. Which means that everything is max is now min and vice versa. So now we go down and say, okay, I'm not going to go up here, I'm going to go down to minimum. Which means the second half, we're going to hit its what? Max. Very good. And you should see that. And all you have to draw, guys, is one cycle. That's it. Yes, we could keep going all the way through. Now, I want to show you something, but you don't have to write this out. You're like, what's the point of showing me? Well, you're going to see why. Here's one way, guys, to think of a period transformation. What's the value of b in the equation? 2. Look at this graph I just drew. In the space of 2 pi, how many times did the cycle occur? Twice. That's what that actually means. That 2, or that number, tells you how many times you're going to be able to perform a cycle in a regular 2 pi gap. That's what that means. So when you see the idea of, oh, what if b is equal to half? Well, that means I'm only going to be doing I'll be able to get half of it down within 2 pi. Just another way of looking at it, okay? How many times can you fit it into 2 pi? Well, what does B equal? B tells me how many times I can put a cycle into 2 pi. That's why you're dividing it by B. You're taking 2 pi and dividing it by B to say, oh, if it's 2, and I need to write it in twice, then how much does each one need to take? And that's there. All right, just want to show you that. All right, let's move on to the next one. You don't have to draw it. You don't have to draw it. If you don't want to. All right, so let's go look at this. What's the period here? Was that what you're asking? Okay. So, it's the period of this one. So what does B equal to here, guys? 1. So that means the good thing is there is no stretch or compression here horizontally. This trig function, this sine function, is still going to look stretch-wise the same. Right, Josh? Yep. So, with our amplitude, what is our amplitude now? 1/2. Which means that in a 2 pi gap, which if you look at the graph, guys, it goes from 0 to 2 pi. How much of this sine are we going to be able to draw? Half of it. Because B is equal to half. We're only going to be able to, I'm sorry, I'm talking about the period, aren't I? Amplitude. Amplitude means how far up we're going, aren't we? So with it being half now, before it was 1, now it's half. So what's that going to do to the graph? Good, you guys got it. That's good. All right, let's go ahead. Is there any horizontal shifts? Yes, which direction? Left, pi over 2. Oh. Now you are in trouble. My pen is out, so it should be interesting drawing from here. All right, so that means amplitude of 1/2, left shift. Is there any horizontal shifts? Is there any flipping or anything else going on? Nope, pretty much it, right? All right, so let's go ahead. Let's draw our, since there's no vertical shifts, is our center still the same? Yes. How far up do we go? 0.5 or 1/2. And then, of course, how far down do we go? Same distance. So there's your center, your max, your min. Did we shift anywhere? Did we do a horizontal shift? Which way? Left, pi over 2. So I'm going to draw a new starting line. It's there. A new starting line is there. All right. Max, min, new middle, new starting line. Everything's done so far. Now let's go ahead and get to our starting points. It is sine, so where do we start again, Trent? In the middle. And how far until we get back again? 2 pi. It's kind of hard because it's not starting with 0, so you get to do math with fractions, but each one of these gaps represents a quarter of it. So 1/2, 1/2, 2. Again, start, stop. What happens in the middle? It's a sine function, so what happens in the middle? It's going to be in the middle. Every time, guys. Every time. When you do sine function, just know your 3 dots will be right through the center. Know your 3 dots will be right through the center. And now you just ask, was there a flip involved here at all? No, so that means our first half we're going to hit our max or our min. Max. Which means the second half will be our min. All All right, let's see how well I can do this with a nub. That'll do. All right. It's not my best, but it'll do. So there you go, guys. As you can see, that compression is there. That vertical compression has now been established because you see it's not so much prominent peaks and valleys. Now they're just gentle slopes, right? Rolling hills. This is being in Colorado. This is being in West Texas. There you go. And those people who have been to Lubbock know exactly what I'm talking about. Pretty flat out there. That actually is it. This is a mountain in Lubbock. My mom has a house. She built it on 8 acres of land, and the house has a gentle, when I mean gentle, I mean a very gentle slope up to where her house is. And she says her house on the hill. And where she sits, I'm telling you, it is about as crowned as a football field. If anybody's seen the sidelines of a football field, if you know football fields are usually crowned, they're like this. She sits there, and where she sits, she can oversee for thousands and thousands of acres because she's just gently above the ground. And of course, her house has a little bit of a foundation. We're not talking much, guys. We're talking maybe the height of this filing cabinet is how much she's different from ground level, and you can see for thousands and thousands of acres. That's how flat it is out there. If you ever go out there, you know what I'm talking about. All right, so let's go ahead, guys, and move on to the next two. I'll get this right sooner or later. All right, y is equal to 2 sine x minus pi. So let's go through and what is the period here, guys? What is the number in front of x? 1. So that means that the period's still the same. What is the amplitude? How far up are we going from the center and down? 2. Is there any other transformations going on? Good. Which direction? Right. That's it. 3 things we have to change. Actually, we're not even changing 3 things. We're only changing 2 things. So, let's go and make that happen. So, as we said before, first step, center. Well, no vertical shift, so center is still center. Amplitude went from 1 to 2, so my new max now is going to go up to 2. And down to -2. And you said it, there is a shift, yes sir.
Always going to be 2 pi divided by the number of x.
Yep, that's exactly right. Always, yep, always 2 pi. For sine and cosine, I should tell you that.
Okay.
Tangent is going to be a little bit different. For sine and cosine, it's always that, okay? So we have a shift to the right of pi, so we go from here, starting line, to now here, starting line. We are talking about sine, guys, so where do we start? In the middle. It takes 2 pi to get out there. What do we know about that right now? Is it going to fit? Because how far should we go out to put our stopping point? If we're at pi, we need to go 2 pi more. How far out should we go? 3 pi, but we don't have it, do we? So I want to make a little bit of adjustment here, guys. And I hope you're using pencil. Sorry, Alex. Let's change this equation to add a 2 in front of the x, which means this becomes 2, and that goes away to where our period now is pi. What does that change? Yep. If we're starting at pi, the period is pi, where are we going to stop? Remember, this gap is whatever that is right there. This gap is pi. So, you start and stop black. Sine function, where's the other dot go? In the middle. The middle is in the middle. We didn't flip, so where is the first half? And there you go. Any questions about sine functions? We've done 3. We've done every transformation there is possible to it. Pretty straightforward. Sine is not bad, guys. I like sine because you start always in the middle and you end in the middle, which to me makes sense. Start in the origin and go from there. That's what we always done when we graph. Start at the origin. Hey, what's your slope? Up and over, up and over. When you plot a point, you start in the origin. Sine's real nice because it starts in the origin. Cosine, not so much. Cosine's a little bit different. Because what is the cosine of 0? What is cosine of 0? 1. In 1, if you look at the unit circle, guys, of all the coordinates, 1 is the highest value you can get as a coordinate. 1 is the highest value you can get on the coordinate. Now, granted, there are transformations that can be done, but we're talking about parent functions. 1's the highest you get. So that tells you that cosine will always start where? When I say the highest, I mean its max. Bless you. You will start with its max, right? So with that being said, we always got to keep that in mind when we're doing cosine. Cosine's a little bit different because we're not starting in the middle. We're starting at the top or the bottom depending on if there's a flip or not, right? All right, let's go through here. Cosine has the same period type equation. I'll eventually switch it to black. Whatever. Amplitude is 1. Any other shifts? Down 1. Left, pi over 2. All right. A lot of stuff happening here, I guess. Down 1. We got to address that first. Our center has been now not the x-axis, but what? -1. Y equals -1 is our new center. That's our new middle. How far do we need to go up? Well, that takes us back to the x-axis. Of course, we go down to -2. For our max, min, and middle line. What about our start? Do we start on the y? No. Another transformation's here. Now our starting point's been shifted. Starting point's been moved over to the left. Pi over 2. So we're here. Now we get to start plotting some dots. Guys, in order to graph a trig function, I should say this. In order to graph a trig function, you need to plot 5 dots. Start, stop, middle, and then the middle quarters. Is that my door? So, start, stop. So, as we said, it's going to be cosine. The cosine always starts with the maximum value, so it starts with the maximum. Because there is not a negative in front, we start at the maximum. How long does it take for it to go back to its maximum again where it started? Look at the period, 2 pi, right? This is Esmondary. Hey. Yes, you bet. Yes, sir. Lauren? Go see Mr. Westby. All right, so there we go. Start and stop done. A little bit different so far, right? Sine was all nice because it was in the center. Now cosine's at the top. This is where it gets a little bit interesting. Sine was great because it's 3 dots right through the center. Cosine's going to look different because we're starting with our maxes. What do you think is going to happen in the center? It's going to be its minimum. So right in the middle is going to be the valley. And then what happens now in between the first half? Well, in order to get from a max to a min, what do I have to cross? I forgot the -1. Ooh, I did. No, the minus 1 is a shift down. Yep. It's like, wait, where? You're right. Okay, there's our 5 dots, guys, so now we can graph. Connect the dots. La, la, la. Connect the dots. La, la, la. All right. I don't know how Ms. Hines did this in 30 minutes. Got to get better at it. She said she can do this in 30 minutes. I was like, man, I'm at 40 minutes right now. All right. I guess she just goes through it. She's quick. All right, so we'll go through it. So our period now, we go ahead. Now here's our new equation, cosine of 1/2 x. Use the equation again. Ooh, guess what? This time I got it. Which is 4 pi. So now what have we done to this graph? Right, now we've horizontally stretched it, expanded it, horizontally expanded it, right? What about amplitude? Is it stretched or anything? It's still 1. It's fine. Is there any other thing that's done to this? No, so we just have a stretch of 4 pi. Now, as you can tell, notice that on the graph, Ms. Hines did this, and she went ahead and she adjusted the scale to fit. If she left it as we did before, we'd have the same problem we were having in a previous problem, which is it would not all fit into the graph. It would run out. But she went ahead and changed it, and it's counting by pi's along the x-axis. So let's go ahead and go through our steps again. No vertical shift, so there's your new middle. Amplitude is 1. Plus and minus 1 along the y-axis is your max and min. Any horizontal shifts? Start is still the same place. Here we go. Cosine starts at max, middle, or min. How long until I get back to the max? 4 pi. Which takes us all the way to the end of the graph. What happens in between? And what happens in the between-betweens? Last one. If I'm going too fast, let me know. I can go back if I need to. But figure by now you've heard the same questions and answered the same ones over and over again. So I'm just kind of going through this. All right. Period. What is the period for this this function for number 6? Good. What's the amplitude? 2. But then also, what else is wrong? We're flipping it as well. All right. Which tells us what, guys? Very good. We are starting at the min instead of the max when we draw this. It's good to know early on. Early on, it's good to know just so you can have that in your head as you get ready for it. That's good. All right. Good thing no shifts, so we go ahead and draw our middle. Amplitude is 2, so we go way up here at the very top. We're also going to go down to -2. No horizontal shifts, so we're still starting at the y-axis. And just like Trent said, we got to start this. However, the parent function starts at the max. But we have a flip that's involved. So now instead of starting at the max, we're going to start at the min. 2 pi later, we end up in the min. In the middle, we're in the max. And in the in-betweens, we're in the center, or the middle.